Welcome back, AP Statistics students. It's nice to have you back. So this is mock exam number 3. Again, these questions were written by textbook authors, Daren Starnes and Josh Tabor. Nice guys. And this is the 15-minute FRQ. So I think it's if I were to make bets, and I'm not a betting man, well, not all the time, but if I were to make bets, I would guess that the 15-minute question would be the probability question. And then the first question, like the one we just had, would be like comparing distributions and doing significance tests and stuff like that. But we'll see. I'm excited to see what the test development committee has cooked up for us this May. So here we have a two-way table. It's a pretty good guess that the probability question will be a two-way table. And that's because since calculations and calculators aren't required and the calculations are low on this year's test, they really, it doesn't seem like the test development committee can write questions that have like a binomial or geometric probability that is calculator heavy. So let's check this out. We have in a sample, 4.5% of people experienced a CDV cardiovascular disease question or event. To what population can this result be generalized? So here we're told that there was 3,462 randomly selected adults from Lausanne, Switzerland. So due to random sampling, researchers can generalize to the population from which the sample was selected, all adults in Lausanne, Switzerland. It sounds like since it's a long-term study that they followed individuals, that they recorded their napping frequency and recorded if they ever experienced a CVD. So this sounds like it would be a prospective observational study. It's not an experiment. They didn't randomly assign who gets to nap and who doesn't get to nap. If they did, I would volunteer to get to nap weekly. And it doesn't sound like a retrospective study. Now that, the data is right before us. So if we wanted to do a study on this, it would be retrospective because the data is already collected for us. But as they were actually in the process of collecting the data, it was a prospective observational study that they were tracking people into the future. The next question says, multi-part probability question here. One person from those surveyed will be selected at random. What is the probability that the person selected will be someone who reported taking at least 3 naps a week? At least 3 naps a week, that would be 3 to 5, 6 to 7. So we'd need at least 3 naps a week would be all these people out of the total. So we have 411 plus 370 out of the total. You could leave your answer like this if you want to save time. Some of you expressed not having enough time for everything on some practice exams. So you could leave it like that. The answer you wouldn't want to put is to just put this answer. If you only put that, then you're either going to get a partial or incomplete because we have no clue where that number came from. Is it possible that you got that number by dividing the wrong numbers? Yeah, there have been AP questions where you can get the right answer by dividing the wrong numbers. So you definitely want to show work and show this fraction. Part 2, what's the probability person selected will be someone who's experienced a CVD event given that the person reported at least 3 naps per week. So this is a conditional probability. And the condition is our denominator. So we want these people to be the people who nap at least 3 times a week. So the way that I like to do that, given that they have at least 3 naps a week, that would be all these people these are the people who have at least 3 naps a week. So we're going to ignore all these people for now. Just looking at those, what's the probability they experienced a CVD event. So the yes CVD event would be these people within that squared out group. So we have 22 plus 28, 22 plus 28 over our condition 781. I don't recommend writing the probability notation, but I know that some people like to do that. Just to connect it back, this formula is on the formula sheet. So we'd say probability they have a CVD event given. I'll do 3 plus for the event of napping like that. So with the formula, our denominator is the probability they get 3 plus, that's our condition. And our numerator is the intersection of having a CVD event and intersection, the 3 plus. So the probability of 3 plus, we had calculated above, that was 781 over 3462. And then the intersection, the intersection of the two, that would be the 22 and 28. 22 and 28 was 50 out of the total. And notice the 3462 is going to divide out, and you're left with 50 over 781. And that's what we had. Again, you can leave your answer like this. If you'd like to write it out, calculate it, you can do that. But again, not required to do that. And then the next part, we're told that one condition is that the number of people who experienced the CVD event and the number who did not experience is at least 10. Explain why this is a necessary condition for inference. This condition is necessary because the formula for the confidence interval relies, so there's the confidence interval right there that they calculated for us. It relies on the fact that the sampling distribution of p hat f minus p hat I is approximately normal. This will be the case if nf p hat f, nf 1 minus p hat f, ni p hat I, and ni 1 minus p hat I are all at least 10. So ultimately, we do this because we want our sampling distribution to be roughly normal. And be very generous in your use of approximately and roughly on the exam. That's a good example of the exam not asking to check all the conditions, but specifically a stealthy way of asking about a condition check. Interpret the confidence interval. So the confidence interval we were given is 0.0062, 0.0435. So we have, we are 95% confident. So we've stated our confidence that the interval, we've used the interval, captures the difference in proportion. Maybe we can even include the unknown difference in proportion, or the true or actual difference in proportion, just to make it clear that we're not talking about the sample. Of people who've experienced the CVD event among those in the population, oh, there it is, those in the population who would report frequent napping, and the proportion who have experienced in the population who would report infrequent napping. So we have our confidence, we have our interval, we have our statistic, our parameter, I should say, in the population that we're seeking to estimate. And then we have context. We've mentioned napping and CVD events. And then we have a last statement. In other words, we're 95% confident that the proportion of people who've experienced the CVD event is between that many percentage points higher for frequent nappers. That's not required, but in layman's terms, that would probably be part of the journal or a newspaper article or something, more than the first sentence that we had. I'll just throw out a reminder that if you're asked to interpret the level, we'd say something like in repeated sampling. We expect about 95% of intervals to capture the true difference in proportions of people who've experienced the CVD event and those who have not, with some context in there. So that's the level. On past exams, that wasn't as likely to be asked, but it seems like on this year, since it's more interpretations and concepts and things like that, interpreting the interval and the level would be much more fair game. And I wouldn't be surprised. Maybe they'll have a interpret the interval and the level all baked in, baked into one question. And then lastly, again, this is a 15-minute question, so we're probably running out of time. It takes probably about 15 minutes just to write all that context. Letter E, even though all the values in the confidence interval are positive, a cause and effect relationship between napping and CVD cannot be established from the study due to possible confounding. Identify a confounding variable. Oh, I really like these questions. A confounding variable. Justify your answer. So on the previous question, we reviewed confounding with the barbell curls. But let's see what confounding variable they chose. They said age is a possible confounding variable because it could be related to both frequent napping and CVD for the adults in the study. For example, this is very, very good to include an example, particularly with confounding questions, to come up with an idea of, hey, how might some other variable lead to the response that would kind of get in the way of our treatment revealing the response. So we have older adults probably tend to nap more frequently and also tend to experience more CVD events than younger adults. If both of these are true, then the result of the study would have been found even if napping frequency has no effect on the likelihood of having a CVD event. So they have older adults probably tend to nap more frequently and also tend to experience more CVD events. So let's say in our study we had more napping, and let's say we napping, and let's say that we found the statistically significant connection between more napping and more CVD. Now, as a side note, that'd be really sad because I'm looking forward to more naps and I really hope more napping doesn't lead to more CVD. But in our study, this was just a bunch of adults in Switzerland. Maybe there's this other confounding variable, age, and maybe, like they said, the older age people, they're more likely to nap frequently, and they're also more likely to have more CVD events. So that kind of breaks this connection there, not equal to, that breaks that connection. And now we don't know, is it the napping? Is napping leading to more CVD events? Or is it the age that's leading to more CVD events? And that's the very issue. This is confounding. We don't know what's leading to the response. The difficult part, though, for students, if they answer this, they would probably say, they'd say, pick some variable, maybe they say age. Age might lead to more CVD, but they don't actually make this connection. They don't actually say not only are older people more likely to have more CVD events, but also older people are more likely to nap. So you have to make this connection, and that's the one that typically students forget to mention or don't mention. Let me look at maybe another example of a confounding variable. Let's say that we found less napping, and these are the type of examples that are really, really good. These are the concrete. Give a concrete example. Give a concrete example when you're asked to describe confounding. So let's say we found less napping associated with fewer CVD events. All right, so let's say we have a low p-value, we're going to reject the null, but it wasn't an experiment. We didn't randomly assign napping or not napping. So then what would a possible confounding variable be? Let's say exercise. So now we would say this link is probably the most important frequently missed link right here. We'd say people who exercise may be less likely to nap because they're healthy, they're in shape, they're exercising rather than napping. And people who exercise, they may also have fewer CVD events because they're healthier, right? So now we don't know that it's the less napping that's led to, or the cause of the fewer CVD events, or if it's the more exercise that's leading to fewer CVD events. So then we don't know, is the less napping, less naps, fewer naps? Okay, I'll just keep it out less. Sorry about that. Is less napping leading to fewer CVD, or is the exercise, don't know what letter that is in there, leading to fewer CVD? So this idea is that we have confounding. So that's just another example. You don't have to give both examples, but I would encourage you maybe to create this, this confounding triangle here, and make sure you address each side of the triangle in your discussion. Thanks for watching this video. If it was helpful, if you liked this video, feel free to give me a thumbs up below, and please message me if you have any questions. Again, thanks for watching these videos and doing the hard work of preparing for the AP exam in light of a difficult time that we're living in right now. Have a great day.